For 3 decades, global navigation, positioning, and timing functioned under a monopolistic architecture. The United States GPS served as the invisible backbone for international finance, global logistics, and coordinated military operations. For rival powers, this meant that essential domestic infrastructure relied entirely on a foreign-controlled constellation. This vulnerability was crystallized in July 1993 during the Yinhe incident, when the United States allegedly degraded GPS signals to disrupt a Chinese cargo ship. Beijing's fears regarding technological reliance were validated. The risk of external coercion was no longer theoretical, it was an active operational threat. In response, China initiated a state-led 3-phase strategy to elevate its technological prowess. They completed the domestic BDS-1 demonstrator by 2000 and expanded to the regional BDS-2 system by 2012, establishing the hybrid orbital mechanics that define the system today. Developing an independent network was a strategic necessity to prevent strategic blindness. By achieving sovereign capability, China secured a spatial infrastructure that is immune to external signal denial, ensuring its military and economic operations remain under domestic control. Unlike GPS's uniform shell, China built a 35-satellite hybrid topology. 3 geostationary satellites anchor the Asia-Pacific, 3 trace an inclined figure 8 to reach deep urban canyons, and 24 medium Earth orbit satellites provide global coverage, ensuring 4 are always visible, mimicking GPS. This specific geometry creates a massive signal density in China's primary sphere of influence. In the Asia-Pacific region, receivers can track between 12 and 16 satellites simultaneously, a density that significantly accelerates location fixing and enhances reliability in heavily obstructed environments. To achieve global adoption, China had to move away from the isolated, proprietary frequencies of its legacy system. The shift to the global BDS-3 architecture required a strategic redesign of how the satellites actually broadcast to the ground. This radio spectrum chart shows the result. China overlapped BeiDou frequencies with existing Western constellations. B1C and B2A signals perfectly align with GPS bands. Tracking these dual frequencies allows hardware to mathematically eliminate ionospheric errors, improving horizontal accuracy to within 3 centimeters. By matching these frequencies exactly, China removed the need for disparate hardware pathways. This allows a single antenna to capture GPS and BeiDou signals simultaneously, effectively embedding BeiDou capability into the global semiconductor supply chain by default. While GPS functions strictly as a passive, one-way beacon, BeiDou integrates a native 2-way communication architecture known as short message communication. This architecture functions as more than just a map. It is a global messaging network. This messaging is now built into standard consumer electronics. These devices can transmit single messages of up to 14,000 bits regionally, including low-resolution imagery, and 560 bits globally, all without requiring the specialized external antennas traditionally needed for satellite phones. Mechanically, these satellites function as bent pipes. A user's message is transmitted into space, but the signal is then routed down to a centralized terrestrial master control station in China. The station processes the precise location, logs the data, and routes the message to its recipient. This architecture introduces a permanent surveillance factor. Because the positioning and routing are handled at a centralized Chinese ground station, the operator can monitor real-time locations and communications of every active transmitter, creating a persistent data log absent in the passive GPS architecture. Beijing derives significant structural power from this network, using BeiDou as the spatial and temporal anchor for the digital Silk Road. It serves as the foundational infrastructure for the broader Belt and Road Initiative. China exports integrated technological packages, from 5G networks to automated port management, that are all synchronized via BeiDou atomic clocks to an accuracy below 30 nanoseconds. This ensures the structural stability of the critical infrastructure in partner nations. By embedding these standards into the foundational systems of emerging economies, Beijing creates long-term technological lock-in. Once these systems are integrated, the financial and operational costs of switching back to alternative technologies become prohibitively high. Beyond the public signal, BeiDou transmits an encrypted restricted service. While the public accuracy is roughly 3.6 meters, this military-grade signal provides accuracy down to 10 centimeters, offering high-fidelity timing and robust resistance against jamming and spoofing. China has integrated this restricted signal into its foreign arms sales to cement strategic partnerships. In 2018, Pakistan became the first foreign nation granted full access, allowing its armed forces to transition naval and artillery assets away from US-controlled GPS. This transition is visible in the global proliferation of Chinese uncrewed aerial vehicles. Platforms like the Wing Loon 2 are now utilized across the Middle East and North Africa, using BeiDou for target acquisition and long-range reconnaissance missions. Faster, more urgent tone. This shift creates severe regional security challenges. India, facing strategic encirclement, has pushed to deploy its sovereign NAVIC system to ensure independent positioning, while simultaneously addressing a surge in signal spoofing and interference against its civil aviation fleet. By providing an independent, unjammable navigation source to its allies, China directly undermines the historic ability of the United States to control the tempo of foreign conflicts through the denial of space-based infrastructure. Looking toward 2035, China is integrating massive low-Earth orbit satellite networks into the BeiDou framework. These satellites orbit much closer to Earth, providing the signal strength needed to overpower terrestrial interference and facilitate high-bandwidth direct-to-device communications. Global reliance on BeiDou has become a paradox. It provides a robust engineering backup for the modern digital fabric, but cements a long-term technological dependency. The era of unilateral American dominance is over. The balance of economic and military power is now dictated by the invisible transmission of microwave signals.